Good day to the panel. My name is KOK YU YUAN, and today I will be presenting my final year project titled Songket Motif Classifications Using Deep Learning for Automated Cultural Heritage Preservations.
Hey Yuan, why you look so confused?
I'm confused in classifying the different motifs. It's so complicated.
So why don't you try the GLCM method or the graph matching image processing approach?
I have think that before, but what's the problem is GLCM and graph matching face the problems like environment sensitive to light foldings, and also it rely on handcrafted features. And the most important problems is it faces the limited dataset for now on. So I've decided to classify the motif with the traditional method.
Oh, so why don't you try the deep learning approach?
Oh yeah, you give me an idea. Why not I design my own CNN-based deep learning to classify the Songket motif? So what I'm going to do is to prepare my own dataset and design a system capable to classify the Songket, and lastly to evaluate the performance of different models.
That sounds like a good idea. Alright, I will leave it to you then. Good luck, Kok.
This project focused on three different but unique Songket motifs: Pucuk Rebung, Bunga Pecah Lapan, and Tampok Manggis. These motifs form the three classification classes used throughout the studies. And these are the examples of the collected Songket images sourced from books, research papers, and online resources. Some of them even sourced from the local stores such as Maidin, Lotus, and Ipoh Parade during the Hari Raya seasons. The dataset was organized and labeled according to the motif categories before being used for training and evaluation. Next, four CNN architectures were evaluated. AlexNet was used as a baseline module due to its simplicity. VGG19 is a deeper network with stronger feature extraction capability. GoogleNet uses inception modules for multi-skill feature learning. And lastly, ResNet50 uses residual connections, allowing deeper learning while avoiding vanishing gradient problems. These architectures were compared in terms of accuracy, F1 score, precision, recall, and latency. The methodology and workflow consists of four phases. First, data collections and labeling. Second, image preprocessing and augmentations. Third, model training using different CNN architectures. Finally, performance evaluations on the test dataset. The implementation was developed using PyTorch with GPU accelerations for efficient training in visual environments, VS Code using WSL Ubuntu. After the data collections for raw data, we move to the next wave dataset and preprocessing. Initially, around 360 images were collected. To improve model generalizations and reduce overfitting, data augmentation techniques such as rotations, flipping, perspective transformations, color jittering, affine transformations, and scaling, which is to simulate the real-world scenario for the Songket motif fabrics, were applied to the raw data. This expanded the dataset to more than 3,600 images, and the examples are shown compared with the original image with the augmented versions used for model training, validations, and testing later on. Next, we will look into the result and analysis. The bar chart shows the overall classification performance. ResNet50 achieved the highest accuracy of 99.6% with an F1 score of 0.99. Second, VGG19 achieved 93.43 accuracy, F1 score 0.98. Then AlexNet achieved around 92.87%, F1 score 0.93. And lastly, GoogleNet recorded the lowest performance, 49.5%, F1 score 0.42. This result indicates that ResNet50 is the most suitable architecture for Songket motif classification. Looking at the F1 score chart, ResNet50 achieved the highest F1 score, indicating its ability to classify all three Songket motif classes accurately. Furthermore, the precision recall graph shows that ResNet50 maintained the best balance between high precision and high recall across all motif categories. This demonstrates that the model is both accurate and reliable, making it the best performing architecture in this study. Besides accuracy, latency was also evaluated. AlexNet achieved the faster inference time but with the lower accuracy, while VGG9 achieved higher accuracy but had the highest latency due to the parameters itself. ResNet50 achieved 99.6% accuracy with only 5.86 millisecond per image latency, providing the best balance between accuracy and efficiencies. Therefore, based on all the evaluation matrices on these tables, ResNet 50 was ranked first, followed by VG19, AlexNet, and the last is the GoogleNet. The key finding of this project is that ResNet 50 achieved 99.6% classification accuracy while maintaining real-time performance with an inference time of only 5.86 milliseconds per image. The result also demonstrates that deep learning significantly outperformed traditional image processing approach for Songket motif recognition. So, a functional prototype was successfully developed using the trained ResNet 50 model. The system allows users to upload the Songket images through a web or mobile interface and receive an instant motif classification result. By scanning through the QR here, we can look at the system together. And then we will see the live implementations of the system on the mobile phone and web page. For the first function we have in this system is single classifications by using different models. And afterwards, we are able to perform model comparisons by comparison the classification performance on a single motif we select and uploaded on it. And the third functions we have is batch image processing. We're able to select multiple images at once. After we select, the models will automatically classify each image belongs to what classes of motif by listing out the confidence levels, and besides it can be downloaded the result as CSV file as shown in the slide. And the last function is listing out the model information for ResNet 50, VG90, GoogleNet, and AlexNet by listing out the parameters and the advantages for each model. Then, this project aligns with several sustainable development goals. First, it supports cultural heritage preservation by digitally documenting and classifying traditional Songket motifs, helping to safeguard valuable cultural knowledge. Second, it promotes inclusive access to heritage information by providing an AI-powered system that can assist researchers, museums, students, and the public. Third, the automated classification process reduces the need for extensive manual inspections and physical handling of textile, supporting more efficient and sustainable heritage management practices. In conclusion, all project objectives were successfully achieved. A comprehensive Songket motif dataset was developed and expanded from 360 images to over 3,600 images through data augmentation techniques. 4 CNN architectures were evaluated and compared, which are AlexNet, VG19, GoogleNet, and ResNet 50. Among them, ResNet 50 achieves the best overall performance with 99.6% classification accuracy, an F1 score of 0.99, and a low inference time of 5.86 milliseconds per image, demonstrating its suitability for real-time Songket motif classifications. In addition, a functional web-based prototype was successfully developed, proving the practicality of applying deep learning for automated cultural heritage preservation. For future work, the system can be extended to support additionally Songket motif, textile authentication applications, museum cataloging system, and broader deployment across mobile and web platforms. With that, I have come to the end of my presentations, and thank you for your time and attention.